Today we're going to look at inverse trig functions. And I want to think back to when have we used sine inverse, cosine inverse, and tan inverse before. If we think about that, we've used them when we knew two sides of a triangle and we were trying to find an angle measure. So if we look at an example, I call that theta. If this is my angle, I have an adjacent side and I have an opposite side. So what trig function would I use for that? I would use tangent. Opposite over adjacent. So I have the tangent of an angle is opposite over adjacent. And to actually get into that angle, to figure out what theta would be, I'd have to take the tan inverse of that to actually figure out what that angle would actually be. So I turn my calculator on and make sure I'm in degree mode. I'm trying to find a degree. And I'm finding the tan inverse, so I press second tan of 4 divided by 5, and that gives me 38 point, we'll round to the nearest tenth, 38.7. Whoa, I'm going percentage. Whoops. Alright, degrees there. 38.7 degrees. Okay, so now if we think about a unit circle, if I say, what is the cosine inverse of 1/2? And I say you cannot use your calculator. You have to think about the properties you know from a unit circle. So I get my unit circle over here and I look at my unit circle and I think about all the properties. Where is the cosine 1/2? Remember, cosine are your x values. So cosine is 1/2 at 60 degrees. And cosine of 1/2, positive 1/2, again at 300, down here at the bottom, at 300 degrees. So cosine 1/2 could be 60 or 300. Well, how do I know which answer it is I am looking for? So what we need to do is we actually need to, before we can start solving these types of problems, we need to restrict sine inverse, cosine inverse, and tan inverse to certain quadrants. We need to restrict our answers in a certain way. So let's look back at our unit circle for a second. I wish I could get this whole unit circle out here. That's a little bit better. So I'm looking at my unit circle, and let's think about sine, for example. Like, let's say I want to do sine of the sine inverse of 1/2. So that would mean, where is the sine coordinate 1/2? Well, it's 1/2 at 30 degrees. And again, it's at 1/2 at 150 degrees. But I don't want two answers, so we are going to immediately eliminate one of these quadrants. We're going to eliminate the second quadrant. Okay, we also need to look down here. Where is sine negative 1/2? Well, again, it's at either 330 or 210. So because I'm already using the first quadrant, this is a good zone, I'm just going to come down here and use all sine. We're going to restrict sine to these two quadrants. So sine is restricted between, if we take clockwise, I call this negative 90, all the way up to 90. So all numbers greater than or equal to negative 90 or less than or equal to 90. Sine is going to be restricted to the first and the fourth quadrant. Okay, so sine is going to be restricted to the first and fourth quadrant. We're going to use that same logic with cosine. So let's look at another. We have our unit circle again. What quadrants should we restrict our answers to for cosine? If we say cosine, again, for example, of 1/2, so we're looking at the x-coordinate, well, cosine is 1/2 here at 60 degrees, and again at 300. So again, I don't want two answers. So for cosine, we're just going to eliminate this fourth quadrant. We're not going to use it. We're going to use the first one for cosine. But then again, we need to look at negative values. So cosine, like say negative square root of 3 over 2. Well, it's again square root of negative square root of 3 over 2 right here, so it could be 150 or 240. We could use the first and the third, but I don't want to separate them. So I'm just going to eliminate this one, and we're going to say cosine is going to be restricted. Cosine is going to be restricted to the first and second quadrant. So what values is that between? That's between 0 and 180. Let's write that mathematically though. Between 0 and 180 degrees. Okay, 0 to 180. So cosine is restricted to the first and second quadrants. And the last one we need to do is tangent. In tangent we have to be very careful with though, because tangent, remember, tangent is your y value over your x value. Okay, so if we look at our tangent of this value in particular, we take the y 1 over 0. Well, dividing by 0 is undefined. And again down here, dividing by 0 is undefined. Okay, so that's undefined both places. So tangent, what we're going to look at is we're only going to look at these two quadrants, but we don't want to, we want all numbers that are going to be greater than 90. So I read this backwards. All numbers greater than negative 90 degrees, not equal to, notice, and less than 90. So between negative 90 and 90. So for tangent, I am looking at the first quadrant and the fourth quadrant. If you did not write these down, go back into the video and write these down. Tangent is the first and fourth. So just to recap, so we have sine is restricted to the first and fourth. So in sine, I'm only looking at these two quadrants. These are the good ones. For cosine, I'm only looking at the first and second quadrant. So I only want these two quadrants. And for tan, I only want the first and fourth, but it's restricted because remember we don't want negative 90 or 90 because the points are going to be undefined at that place. So first and fourth again. Okay, so there's what we just reviewed. So one thing that we want to talk about real quick is sine inverse, cosine inverse, tan inverse. There is another way to write this. If I say sine inverse, that's the same thing as saying my arc sine. Or if you see cosine inverse, you could say arc cosine or arc tan. Those are all the same way to write the same thing. Doesn't matter. Okay? So let's actually look at some examples and see how this applies. So if I have, say, the cosine of the arc tan of 1, I need to think, oh my goodness, what is going on here? So the first thing I need to think about is what angle is it when tangent equals 1? Well, we only have two types of triangles that in this thing. We have a 30, 60, 90 triangle, and we have a 45, 45, 90 triangle. And remember, tangent is the y over the x, opposite over adjacent. So if we think about this, our two types of triangles, opposite over adjacent, if I divide these are not going to give me an answer of 1, so the 30, 60, 90 triangle's out. But when I divide opposite over adjacent, 45, 45, that gives me square root of 2 over 2 divided by square root of 2 over 2. That's going to give me an answer of 1. So this must be a 45-degree angle. So then, if this inside, if I've solved that to be 45 degrees, then I got to think, what is the cosine of 45 degrees? Well, cosine of 45 degrees, cosine is adjacent over hypotenuse. If you forgot, think of SOHCAHTOA, adjacent over hypotenuse, square root of 2 over 2 over 1. So square root of 2 over 2. And I could also check on my unit circle. Square root of cosine of 45. Remember, for cosine, I'm using the top two quadrants. Cosine of 45 degrees, square root of 2 over 2, and that's my answer. You can look at another example. So if I think of the cosine inverse of sine of 3 pi over 2. So first I just have to think, well, what's 3 pi over 2? So think about, if you have this in radians, you could first change it into degrees. If you have it memorized, you could look at your unit circle and you could say, well, 3 pi over 2. How many degrees is 3 pi over 2? And I remember, yep, that's 200, oh, you can't see it, sorry. It's 270 degrees. So, and the sine value, now look at, we're looking for the sine of 3 pi over 2. Sine is your y value. So here's 3 pi over 2. The sine value is -1. The y value is -1. So then I'm thinking the cosine inverse of -1. Well, what angle is it that gives me -1? Well, I think back to cosine. Cosine, where is cosine going to be -1? And I think it's got to be the first quadrant and the second quadrant are cosine, and cosine is your x value. Where is it -1? That's right, it's right here at 180 degrees. So the theta here is 180 degrees, or the cosine inverse of -1 equals 180 degrees. Not easy problems, but they're definitely doable. Okay, and the last example we're going to do today, if I say that I want to find the tangent when the arc sine is 24 over 25. Now that doesn't look familiar at all, so I got to break it down and actually draw a triangle for this and think about it. So I'm thinking about, what is the angle when the sine is 24 over 25? Well, let's draw a right triangle and call one of the angles theta. Sine is opposite over hypotenuse, opposite over hypotenuse, and I can do the Pythagorean theorem to find this third side. A squared plus b squared equals c squared. So we calculate this, 24 squared, we get 576, 25 squared, 625. Subtract 576 from both sides. So a squared equals 49 square root. The distance here is 7. I found that to be 7. So now I just want to know the tangent though of theta. So tangent is opposite over adjacent. Tangent is the TOA, opposite over adjacent. Opposite 24 over adjacent will be 24 over 7. So the tangent of the arc sine of 24 over 25, opposite over adjacent. And that's my final answer. So give the worksheet a try, 13-7, and go from there.